All right, hi everyone. Let's go ahead and get started with our next chapter. We're going to be looking at triangles for this entire next unit. So we're going to start by looking at their classifications. So just like science has classifications for their animal and plant kingdom, we have classifications in geometry for our triangles as well. So when we classify triangles, every triangle gets two kinds of names. They get one name that describes what's going on with the angles, and they get a second name to describe what's going on by the sides. So we're going to take a look first off at the angle kinds of classifications. So every triangle, regardless of how big it is or the shape of it, it always has three angles going on inside. Now, when all three of those angles are all acute, so less than 90 degrees, but bigger than 0, that's when you get an acute triangle. So again, all angles are acute. And that's what makes an acute triangle. They all have to be less than 90. Now, we also have what's called an obtuse triangle. So in this case, we have two acute angles and one obtuse angle. And that's what gives us an obtuse triangle because of that one obtuse angle. So one obtuse is extremely important here. Now, a right triangle gives us two acute angles and one right angle. So one of the angles in this kind of triangle have to be right, which means it needs to be exactly 90 degrees. So it's okay if the other two angles are acute, but again, if there's one that is exactly 90, that is our right triangle. Now, the other classifications of triangles that we get do come in to the sides. So when we start looking at the sides of triangles, it's all about how long they are. So now we're looking at what's called a scalene triangle. And this means all sides are different. Or you can think about it as no congruent sides. Now we're going to look at what's called an isosceles triangle, which is a triangle that has at least two congruent sides. So it's going to have at least two of them. And then our last one, equilateral. So this one's more friendly because again, it's got equa inside there, which is very similar to the word equal. And lateral, meaning sides. So an equilateral triangle means we have three congruent sides. Or you can think about it as all sides equal. So let's look at some examples of these three real quick. So I'm just going to draw some pictures up here and I'm going to work my way backwards. So looking at equilateral. So even if we don't necessarily have numbers involved with this kinds of triangles, remember you have your congruence marks. So if there's the same number of congruence marks on all sides of the triangle, then again, it is equilateral. So I may not know the measure, but I know at least they're going to be the same size. Continuing working backwards, isosceles, again, we have two sides that have to be the same. So only two sides might have the matching congruence marks, maybe 1 dash and 1 dash. So those two longer sides for this specific picture would be my two congruent sides. And then we've got scalene. Again, that could be a triangle with no sides the same length. So we could have a different number of dashes on each side, or there may not be any markings at all. So that's just a little side note. Because again, if there's no markings, then again, they're not telling you that any sides are congruent. So if they're all sides are different lengths, you don't have to necessarily put those dashes there to indicate that they're different, like we did in the example. So just keep that in mind. Now, moving right along, when we go to our angles, again, for a right triangle, there has to be an angle in that triangle that has exactly 90 degrees. So it could have the actual number 90, or it could have the right angle box. For an obtuse, we need at least one angle that is bigger than the other two, that is more than a right angle. So you've got your one obtuse there. And then when we look at acute, all of the angles must be less than 90. Now, I do want to have one little side note here for an acute triangle. There is a special case of acute triangles, which is called the equiangular. Which means, yes, all the angles are acute, but all angles, more specifically, are 60 degrees. And that is our acute triangle. Now, how do I know that in an equiangular, they're all supposed to be 60? Well, that's because we have our next theorem, the triangle sum theorem. And that's what this next one is going to be called, your triangle sum theorem. Which says the sum of the angles in a triangle have to make up 180 degrees. So regardless of how big the angles are and regardless of its classifications, all three angles in this triangle have to add up to 180. So whatever is going on at angle A plus whatever is going on at angle B plus whatever's going on at angle C, added up, they all have to make 180 degrees. And the same can be true. We have another angle that another theorem we're going to look at, which is the exterior angle theorem, that says the measure of an exterior angle is equal to the sum of the two opposite interior angles. Now, those opposite interiors that they talk about in this theorem are also called the remote interiors. Okay, they're also called remote interior angles. So when we look at this specific picture we have here, angle 1 is our exterior angle. It's outside of the triangle. Now, my remote interiors are the two angles that are not making a linear pair with that, meaning they are not going to share a side. So that means angle B and angle A. Those two are my remote interiors. Those are my remote interiors. Angle A and B, while again, angle DCA, or the measure of angle 1, that is my exterior because it is outside of the triangle. So let's see if we can use our classifications now and figure out how we would name some of the different triangles we might be working with. All right, so this first box, circle the acute triangles. So remember, we're looking for the ones that have acute angles with them. So we need angles that are less than 90 degrees. All right, so if I look at this first blue one, all of these angles are less than 90 degrees. So they are in fact all acute. Now our second one that's there, that triangle has all equal sides, which also is a clue to equiangular. Because if your triangle has all sides exactly the same, then all your angles are exactly the same. And this one is also called your equiangular. So in this triangle, if I get those congruent sides, I also have congruent angles happening. All right, let's look at the next one. We have two acutes and 180. That is an obtuse. So I'm not going to circle that one. Next one over, three angles that are all less than 90, that can work. And then our last one that we have here has got a 90, which makes it a right triangle. So I cannot circle it for acute. Okay, moving right down, circle the obtuse isosceles. Okay, so let's first do the obtuse, because obtuse means I need an angle bigger than 90 but smaller than 180. So this green one is out because of the right angle. The one right underneath it with the 40, 70, and 70. Yes, it is isosceles, but none of these angles are bigger than 90 degrees. So it's out. The pink one, the top middle, we do have a 130 and 225, so it's a possibility. The one right below it, 120 and two acute angles, so it's a possibility. And same with the last one, 110 and two acutes. So now we need to focus on the isosceles part, which means two sides that are the same length. So we've got 130 and two congruent sides there because of the markings. That one can work. One right below it though, the 7 and 4, not the same length. And none of them match up with the 10, so we're looking for two sides the same. That one's out. Now we've got 110 for our last one and two 5s. That is another way to say they are the same length. There's our two triangles. Right below, classify this triangle by its sides and angles. So let's do sides first. All right, so we've got two sides that are the same, which makes this isosceles. And our angles, all of these angles are less than 90. So that makes this isosceles acute. All right, let's check out the other column. All right, now we're looking for the scalene triangles, which means all sides are different. There are no congruent sides. So this first triangle has two 8s, two sides the same, it's out. We have one next to it, 6, 8, and 10. All different, that could work. Next one over, 5, 7, and 9. All different, that one can work. Our last one, 4, 4, and 4. All the same, not gonna work for us. Let's check out the one below. Look for the equilateral. All sides are congruent. All sides are the same measure. All right, so looking at this first one, we've got two that are the same, but that third one is missing, so it's out. The one right underneath that, all sides are the same. I'm sorry, all sides are different. It's out. The next one over, 9, 9, and 9, which means they're all the same. There's our first one. One right under that, 5, 5, and 4. So two of them are the same. The third one is not. It's out. The one right above it, even though it's small, it's got a dash on each side, making it equilateral. The one right next to it, 60, 60, and 60. Like I said earlier, if all the angles are the same, the sides are also the same. So that makes it automatically equilateral. And then our last one of a 3, 5, and 7, all different, not equilateral. All right, another classify. Classify this triangle by sides and angles. So we'll do sides first. We've got an 8, a 15, and a 20, all different. So that makes this scalene. Now let's do the angles. I have two acute angles and one obtuse. So this is a scalene obtuse triangle. All right, let's look at our last few statements that are down here. For each statement, decide if it is always, sometimes, or never true. So a right triangle can be isosceles. That is one that is always true. I think we might have had one up in one of our pictures. Yep, this pink one that was here, that is an isosceles triangle. Two sides are the same, and it does have a right angle. So, but that is not always the case. This green one that we had, yes, we have a right angle here, but we don't have two sides that are the same. So this is a sometimes. An obtuse triangle has 3 obtuse angles. That is never going to be true. Because remember, the definition of an obtuse triangle has 2 acutes and only 1 obtuse. So that is never true. An equilateral triangle is isosceles. Well, remember, the definition of isosceles has at least 2 congruent sides. So does an equilateral triangle have at least 2 congruent sides if all 3 are the same? Yes, it does. Because if it's got all 3, then yes, it's got at least 2 that are the same. So this is an always. All right, guys, I hope you like learning a little bit about how to classify triangles given your side lengths and your angle measures. So please don't hesitate to reach out to me, guys, if you have any questions at all, and I hope you have a great day.